All right, my friends, we're going to play with macro data. We're going to look at interest rates across the term structure, and we're going to compute some sample stats. First thing I want you to do in Excel is put one date in A1. Let me make that a little bit bigger for you. And remember, in Fred Excel, add in the one date means give me one date structure, so I have one date per row. I want you in A2 to put M comma average. We're going to call up the daily values, and then comma average, take the daily averages for all the days within a given month. Now, Fred actually has this already created. They have other tickers that look at monthly securities, but I wanted to show you how to do that. We're going to pull from 1/1/1962 through September 2025. And I give you these tickers here, DGS 1 month, DGS 3 month, 6, 1 year, 2 year, 3 year, 5 year, 7 year, 10 year, 20 and 30. That's my favorite. And all Lynn. Remember Lynn? Who is she? I don't know. When you go to data manipulations levels, no transformation. I want the interest rate. I don't want any transformations on it for this exercise. Go to get data and boom, you got all that set up. Now you notice there is some missing stuff in there. Not all the securities were existing or in our database at that same point in time. If you're replicating, you might be asking, how do I get the blues? The basic idea is go ahead and grab the row headers and then all the data that comes out. Once you get all that data, you would go to insert and then table. I've already made it, so mine's grayed out. Then you would give it a name, and you can even extend the table. Extending the table beyond the region allows you to really update in some cool ways. Other videos for that. So what I want to do with that is to compute some sample stats. Now I have mean standard deviation, skew kurtosis, minimum, Q25, Q5, Q75, max, and the count where there's not missing. I want to use the table structure, and I'm in a table. When you click on the table, you go over here. Check this out. Watch right here, if you can see my cursor. Watch right there when I click on the table. Table design comes up. Table design, term table. So I called it term table, term structure table. I'm not very creative. So I created a setup over here, the table name, term table, term table. I didn't need to do this in this way. I've had other videos where I lock it in, but I want to show you different approaches. And what are the column names? Now, I didn't name these. Go back up. By default, Fred calls them value 2, 3, 4, 5, 6. You can try to change that. The problem is when you go and update the data, Fred will overwrite those. So we have to know which one is which. So I wrote these in by hand. You can even color them in blue to indicate the universal indication that it is structured. It's something that's written, not a formula, right? Okay, so value is for the 1 month. Value 2 is for the 3 months, so on and so forth. There's value 9, 10 years, my favorite. So we want to compute all these sample stats. So let's do the mean. Now, what you can do is you can do the equals average and term table. Remember, the tab gives you it, open bracket, and then arrow down, tab, bracket, parentheses, close. So I don't know if I did something wrong. Why would it be NA? Scooch on over. There's a whole bunch of NAs, right? Since there's NAs, when you just blindly drop on an average, it's going to spit at you. So there's a few ways that you can get to that. One thing that you could do is you could turn it clean. You could process that data column to remove any of the NAs. You can use an if statement. So if there's no number there, then give me air quotes. Here's another approach. I want to take the average, but I want to wrap that inside of something. So I want to wrap it in a conditional statement round is NA. But then I have all these indirects. So there's a lot going on in that table, in that formula. So what's happening here? Let's go to the end. Indirect. The indirect function is going to allow you to use text in a cell, wrap it, mold it bind it together to form kind of like a function call for Excel. So it's going to take S14. S is not locked in because I want to keep that column moving as I copy it through. But 14 is locked in, so it's always for that table name row. And then I want to append that to, append is the ampersand you see right over here if you see my cursor. Append that to quotes bracket. Remember, every time we reference, when I referenced it, I had, so that's what I want for that one. And then I want to append that to ampersand S15. What's S15? Value. And then append that to ampersand, the quotes, the ending bracket, just like I had before. All right, so what that's saying is, give me the average for the term table value. Well, that's what I just did. That doesn't work, right? So how do I get rid of all the NA stuff? That's where these conditional statements come in. So is NA, if there's a problem, do something. If there is NA, if in that term table value, hey, this looks familiar, indirect S14, S15. That's just what I have there. So if there's a problem inside of there, anywhere, then give me air quotes. If not, give me whatever are the rows that are there. Right? Remember, that's the way the if statements work. So if something, do an action. If not, do a different action. The way I read this going from left to right is give me the average if there is a problem, is NA. If there's a problem in the term table value. And when there is a problem, give me the air quotes. See my cursor? Give me the air quotes. If there's no problem, then deploy the average over term table value. 1.58. So doing it plainly as average term table value, that code is right, but it's not adjusting for the fact that there's messy data in there. Now I want to take that and I'm going to scooch it on over. Just copy and drag it over. Notice how, watch what, when you click on it, it's highlighting column S. Now it's highlighting column T and U and V. That was because I have the column W, X, Y without the dollar sign, but the 14 and 15 locked in with the dollar signs. That allowed me to drag it through. Okay. I did that for standard deviation and skew and kurtosis and min. We've done all those, you know all those. A little bit less familiar perhaps with the quantiles. This is the 25th quantile. So what is the value of the 1-year month treasury bill in the term table at the 25th quantile level? So what this is, the function here is saying, give me the array at that quantile value. Give me the array at that quantile value. You see how I'm clicking on it? When you go inside of a formula, you click on them, it shows you which piece of the entry you need. And all this junk over here, I'll try to highlight, is just like before. It's all the if, is, and a indirect. So we're still taking that same kernel, but we're putting it into different functions. For the 50, all you need to do is change what's out here. For the 75, all you need to do is change what's out there. And then the max, deploy with that max. And you can count. This should look familiar. We're still going to use the indirect, the S14, S15. No problem with that. And then what I want to do is count if, not ifs, but we could do that. The only difference with the S is how many criterion. If that is not equal to NA. So the quotes less than greater than means not equal to NA. So count the number that are not NA. There's a lot more of these later securities in that 1 month treasury. Let's scooch over. So check this out. Follow me on the way down. 1 month, 3 months, 6 months, 1 year. Well, wait, there's no NA in the 1 year. There's a lot more 1 years, pardon me, 1 years than the 6 month, 3 month, and the 1 month. That's why, because they didn't exist at the beginning of that data set. Now, You can take a look and you can see that the most volatile is 2-year. There's lots of theoretical reasons is that belly of the curve, it's not quite just Fed, it's not quite long-term inflation and all that stuff. And the highest, I only actually highlighted if yours isn't colored. Highlight and then color the cells. The average mean interest rate for the 1 month is the lowest. The red doesn't mean negative, but it's the lowest. And the 30-year is the highest. There's a deep theory about the slope of the yield curve, the maturity spectrum. Interest rates of a longer maturity, greater risks, greater duration risk, greater opportunity costs, which are missed. You need to compensate, hence higher interest rates, and less over here. These are all, think of them as annual rates. In terms of the volatility, it's the smallest at the 1 month as well. Smallest mean, smallest standard deviation. So you would think if we have this notion of the longer I part with my money, the more risk I'm taking. So there would be more volatility. And the shortest that you go, well, there's less time passing, so there's less volatility. You could think of it like that. But here check this out. What if I computed the standard deviation divided by the mean? There's a name for that, and it's called the coefficient of variation. It kind of gives you the level of risk per unit of return. In asset allocation, they talk about this a lot. The unit of risk per unit of return. How much risk am I taking per bang for the buck, if you want to think of it like that? For the 1 month treasury, 1.15, the 30-year, 0.5. So for the 30-year, I'm taking on 3 units of standard deviation. Remember, standard deviation was how much it swings. 3 units of that. I'm being compensated by 6 percentage points, let's say. For the 1 month, I'm not swinging anywhere near as much, almost half of that, 1.8, but my compensation is only 1.58. So in terms of the amount of risk I'm accepting for a unit of return, that 1 year is actually pretty darn high, the highest among all of them at 1.15, coefficient of variation. All right, my friends, I hope that helps.